Top of the day to you. We're back at the kata. Kata called Castle of Cubes on this day. Maybe there's a lot on the screen right now, and as I said again, I've got all the stuff written out over here. Written out over here. It's just that the matter of transcribing it to the computer and the program. So we could do a swell with flash slate, just like the last time. Alright, so I have figured out kind of a system. Basically, we need to make a self-creating information that cannot be hard-coded, and it must be related to the... It must like know the exact amount of panels that we're gonna need to use, you know. So right over here, what is the logic? We are building a cube all the time with this castle because cube is most space economic, or panel economic, since we want to use the least panels as possible. And building a cube over here, we're gonna do it in 3 phases. So alright, let us get well, alright, I hope this won't take too long. We say sketchpad. I put that over here. So what are these 3 phases? What are these 3 phases gonna be? So if this is already a cube, you know, this is on the micro level, on the 1 times 1 cube, 1 times 1. We're gonna do first, we're gonna build again one of the same, for example on top, you know, for example on top, and then we're gonna build it in at the side. So there is the second phase, and the last phase, the new dimensions right over here. I might not have the completely right vocabulary. So it's like first, so if we start from 1 times 1 cube to get to a 2 times 2 cube, we first need to build on top of it, so another 1 times 1, and then on sideways we say 1 times 2, and then at the back 1 2 times 2 thing. This is 1 times 1 times 1 cube, and over here we're dividing it into 2-dimensional planes. So this is 3D property, and this is 2D property, yeah. Alright. So this is 2-dimensional plane, and once we get through all of these steps, we get to 2 times 2 times 2 cube. Yeah. These are the phases, and this is what we're gonna do. We're gonna say we got to recognize which phase we are at. So we're gonna say phase count. We start at what? 0. So we got, so for example, this is the 0th one, this is the first one, and this is the second one. And right here we're gonna say if phase count, and this is of course gonna be recursive, you know, and we say if phase count equal to 0. How is the first different? Yeah, we do we increment this one by 1. So we say we start, say phase status is gonna be a tuple with 1 by 1. So we're gonna start at this over here. We're gonna start over here. So that's gonna be 1 by 1, and if phase count 2, we're gonna say phase status. We're gonna pick the first one and we're gonna increment it by 1. Then elif phase count equals to 1, which means if we have already done this one, increment the first property by 1. So we're gonna say phase status equals to 1. And the last one, we say, right now I don't really know what's better to like do else or elif. I'm just gonna do else. So else, so what happens after that? After that it goes on, and it actually looks like this. So now we're at the, with this action we get to 2 times 2 times 2 cube, and right over here we're gonna build on top of it and make another 2 times 2 times 2, I mean 2 times 2 square right here. So we do again 2 times 2, and over here on the side we say 2 times 3, as you can see. So it's 2 times 3, oh 3, and then it's just 3 times 3. So as you can see, this step where both properties are equal occurs 2 times. So right over here, no damn, what are we gonna do is we're gonna say else if this phase count is already plus phase count shit plus equals 1. So else if phase count is 2, we're just gonna say phase status is 1. We're gonna reassign it to 0. Oh, it's running on low power. Let's plug my computer into the Yo, this cat is so adorable. I must resist so much not to pet it. So Oh, and here, oh sorry, yes, because we are also modifying the phase status. You cannot do that to a phase status. I think I'm like hi. Wow, phase count should over here be also plus equals 1, or just like assign it as a 1. And then it goes again, and if phase count phase status, the first one, the 0th one, is plus 1. So, and we do phase count equals to 2 now. And yes, if you're wondering, yes, this is very hard for me. I'm doing massive calculations in my head on every step. And so if phase count equals to 2, we're gonna say phase status. Do not change the phase status actually. Just do the phase count to 0. And so that is the way. And it is kind of confusing for me, for you maybe not. Also, this is wrong syntax right over here. Now it's correct. So let's visualize it. And this is phase 0 as it starts, and right over here we want to do like build shit. Right here we want to build on n shit on n times n, and then we want to increment this by 1, and like phase count 2 we go phase count like here, and over here is want to say build n times 1 plus n. Yeah, just like that. Phase count that, and over here we just telling it to again build of n times n with it, or let's say this is like x, because there are actually only 2 variables, and right here we reassign that to x, and so then x, alright, whatever. Maybe y would be better. Some insane calculations. That's what it looks like. So we get 1 times 1, 1 times 2, 2 times 2, 2 times 2, 2 times 3, and 3 times 3. So we get 1 times 1, 1 times 2, 2 times 2, 2 times 2, 2 times 3, 3 times 3, and it just goes as it goes. I do not know if this is the best way to do it, but that's how I did it, because currently I do not have bandwidth to really think about further if this is the best practice, as there are other things we need to tend to. As we have this n times n square, we must and get an algorithm to build on it. So we're gonna say def construct. So what am I meaning by that? Look, we shall input something by something, for example 3 times 3, and we wanna return, or at least firstly just create what kind of, how much panels are we gonna use to build the whole square. For example, this would be 5 4 4 3, and then it would be, so that is 2 times 2, and then it would get 4 3, and then it would get 4 3 3, I think, yeah. So that should be 9. So this is 1 2 3 4 5 6 7 8 9, yeah, that's 9. So 3 times 3 would return that, for example. So we're gonna say construct panel, or how do we call this property, you know? Construct information. Construct information about the construct array of panels required. Construct array, or list, you know, list in Python is list. Construct, yeah, but it's array if we think about it in broader sense, of required panels. What do we get in? We get this in. So we get a tuple in. So we get a, we're just gonna say tuple. Yeah, so first let us unpack the number from the tuple. So we say number of rooms. So what do we say? We say tuple 0 times tuple 1. So that's the number of rooms, very simply. And what about then? Well, I know that for the first 3, no, the first 4 properties are always going to be 5 4 4 3, and then something else shall always be, and something else shall always be. But yeah, the first one is kind of unique, or at least the the first is kind of unique, you know, because you say 5 4 4 3. So let's take care of that. Number of rooms, all right, and then we're gonna say array of required panels, starts off as an empty list, and then we're just gonna say, so if we get, so for example, if we get 3 times 3 thing, then length of this one shall be 0 1 2 3 4 5 6 7 8, yeah. So then we say while while length of array of required panels is, length of that minus 1 is not equal to number of rooms, we say, and here we are appending it to the here we are just appending numbers, and as you can see, here this is always what it starts with, and then it just a certain pattern of 4s and 3s. So right here we say well, that is less than that. We say we have to make ourselves a helper function called let's just say starter. Starter is always starter array. Starter array is always 5 4 4 3, and we say and if number of if length of array of required panels is, if length of that is less than 0 1 2 3, if it's less than 4, we're gonna say array of required panels dot append. What are we gonna append? We're gonna append the starter array, and we're gonna pick the index of the current length of array of required panels. And right now I'm thinking, should I put this into an array? Oh, no, into a special variable name? Well, let's not do it for now. So else, when we are through with this one, we say we start with the 4, and alright, I need to go to the toilet again. Yeah, I'm back. I am back. Yuhei. For you it was nothing, for me it was something. So I need to get back into thinking. So after we are done with this starter array, there is this pattern that we must do. And over here we again need to have a some kind of a count of the appearances, because as you can see, for example, this, I'm not gonna do it all the way, but this is the vzorec. Kako se reče vzorec? This is the pattern for 8 times 8, but I'm not gonna do it all the way. So it's, and of course it just continues from 3 times 3. It's nothing different, it's just longer and looks like so. So we got 4 3 4 3 3, and then we say 4 3 3 again, and then we say 4 3 3 3, and then say 4 3 3 3 again, and then so we got, and then we got 4 1 2 3 4 1 2 3 4 threes, and again 1 4 and 1 2 3 4 threes, etc. So we get interesting pattern, and if we break it up a little bit, so this is the so-called starter array, and what we get is this kind of pattern. At first it's just 4 3, then it's 4 3 3, then it's 4 3 3 again, and then it's 4 3 3 3, then it's 4 3 3 3 again, then it's 4 3 3 3 3, then it's like that, and then it of course goes on. So right up until here we should get, I think, so we got 1 2 3 1 2 3 4 5 6 7, so we get like 7 times 6, 7 times 6 think over here. I think 7 times 6 is how much? It's 42. So we say 1 2 3 4 5, that's 10, 11 12 13 14, that's 18. Yeah, that's not 7 times 6, but you know, that's the pattern, and we should capture that pattern. And if we start it over here 4 3, we're gonna have again phases, and with these phases we're gonna say with this phase, what we're gonna do is to say phase. So let's say that this is phase 0, this is phase 0, and this is phase 0, and after phase 0 you must append a 3, and then do nothing, and phase 1 you basically do nothing, and at phase 0 you append a 3 again. So here we're gonna say phase count again, and I don't know if this is gonna, like, this scope is gonna leak into here, so maybe we should rename this thing. Instead of phase count, we could say line status number, and it of course starts with 0. So we say else here we're building a whole tuple, so we'll say else over here, and we're gonna say if and of course number of 3 is over here is only 1. And as you can see, like I do realize, this is just a side note, that this could be imagined or visualized as this. So it's like 5 4 and then 4 3 4 3 4 3 3 4 3 3 4 3 3 and stuff. I just choose to do it that way. So number 3 is this 1. So then we say if line status number equal to 0, we say array, we wanna append something to the array of required panels. So at first we always append the 4. So this could be done right over here. Else we say array of required panels the dot append, and we wanna append just a 4, and if line status number is 0, we say array of 3s, and we're gonna use the basic list comprehension 3 for element maybe we could make like a Pythonic way. So we'll say Python make x elements in list non times 10, creating an empty list. It's like that. So we say 3 times number of 3s, array of 3s, number of 3s. So, and then we shall just say yeah, that gets me thinking about some stuff. So we say array of 3s, and then we say array of required panels dot extend, because we use extend every time we append another list, and we say extend by array of 3s. Yeah. So that is the end of this phase, and then we say line status number equals now to 1, or we also want to do so number of 3s is incremented by 1, and line status number is 1. So, and then we make an else statement right over here, elif, and we change that to 0. And the only other thing we change is that we do not increment the number of 3s. So that is that. And while we're at it, we could just as well just say if length is 0, then and just say array of required panels extend by starter array. So that should return us the right one. And then we return. Why is this red? Why are you red? Okay. Huh? Alright. And we return the array of required panels. So I want to test that, so we say Python over here, and that opens up Python thing, so we say Python 3, and that's kind of too long to really get in there. So we quit that. So the documents programming is here anything like a Python sandbox, so we say make directory Python sandbox, Python 3 sandbox, of course, or doesn't matter actually, Python sandbox, and we say change directory to Python sandbox. Shit. Python. Oh, there is a Python sandbox. Well, fuck. Well, all right. Let's be proper. Is a directory rm recursively. So we change to Python. Well, where are you now? God damn it. Where is this? Python. Change directory Python. Oh. Python. Yeah, that's right. A little awkward thing over here is say touch app.py, and we open it in code editor. Copy. Wow, is this thing like taking a lot? Paste, save, and then what we say is that we do ls. We say we run a Python shell over here, and we say from app import construct array of required panels as function, as are like, I don't know if I can just say function. Oh, well, let's try it. Say function, and then we say 3. Construct array of required panels takes one positional argument, but 2 were given. Oh, because it is actually a tuple. Array of required panels is not defined. Yes, alright, so there is 2 ends. Thank you very much. Alright. So we need to quit it and hit it. Then say something. Ah, okay, so we get 3, 4. No, 4, 3, 4, 4, 4, 4, 4. Alright. So what is going on here? We just get 4, 4, 4, 4, 4, 4. So if line status number is 0, oh, and if line status number is 1. Shit. If that's 1. So we copy everything, paste it over here, we quit that, say Python 3, import that function. Oh, okay. Oh, so I guess now we got an infinite loop. Yeah, check this out. If I oh shit, my computer's gonna crash. Oh, alright. Thank you for killing it. Wow. Whoever killed it, thank you. Alright. So apparently we get an infinite loop with this one. How? So this is line status number is. And there is never the correct number of rooms. Well, let's debug it. Else, so we say always over here we say print f string, and we say array of required panels. I don't know if it's panel or panel, I don't know. Is, and then we say over here, yes, the array of required panels. Alright, and see where that gets us. Oh, alright, a lot. Maybe a bit too much. We need to kill it earlier. Okay. Oh, we still. You can never kill it. Oh, we did it. Look, it's over here. Array of, so it's 5 4 4 3 4 3 4 3 3 4 3 3. All right, I like how this is going. 4 3 3 3. And it should end at that. So we say if we get, we paste it in 3 times 3, right? So it should, so let's just check. Let me check over here. It's correct up until here, and then it's 4 3. Oh, it's so hard to read with all these 4s and 3s. So then it's 4 3, and it's 4 3 3, and it's 4 3 3 2 times 1 2, and at that point we got 1 2 3 4 5 6 7 8 9. All right, so even it should end over here. It should end over here. 1 2 3 4 5 6 7 8 9. Well, but this is achievement in and of itself, because what are we doing? Well, it is done infinitely, but what we are doing is that we are constructing an array of required panels. Except, like, in theory it's not wrong, but it's just infinite, you know. It's just infinite, and we need to make it finite, and for not too much, because the computer, as you've seen in previous episodes, it times out because it calculates too long. So this should stop. This should stop, and it doesn't stop. Why doesn't it stop? Well, I just copy that over here. So, just say so. Number of rooms is, or here we say shit, print f something, length of required panels, then say -1. Yeah, maybe I'm just like not understanding the length, because right over here, length, can length be 0? Yes, it can be 0. Oh, it should be nothing. Alright, I think now we won't have any problems anymore. Let's quit it. Let's see, Python 3. Yeah. Oh, okay. Oh, stop it. Stop it. Is there a beginning to this mess? No, there is not. Say quit. Function 3. Ah, cancel it. Sub. We get like colossal numbers of wow. No. Okay. Array of required panels is that. Alright, so we get like a colossal number. So right over here, what are we gonna do is, while length of the required panels, we're gonna say not the number of rooms, but while it is less than the number of rooms. At least I think, I mean, I'm certain that we won't get an infinity. Alright, we didn't get an infinity, so what we do, number of rooms is 9. Maybe I should do it like this. Yeah. Debugging. So-called debugging. Alright. 0 number of rooms is 9. Array of no required. Alright, 4 number of rooms is 9. It's 4, 3. Fair. 6 number of rooms is 9. 9 number of rooms is 9. Alright. So why shouldn't this work? Well, this is not that. So that is the right thing. That is totally the right thing. So if we quit that, try it again. Yeah, we get an infinite. We get an infinity again. Bless you. Alright, so I don't know what's going on. Why do we get an infinity? Huh? Are we using the is not operator wrong? Python is not. Yeah, we have the same value. Are the same thing. Okay. So I do not know why that happens. So we should just say that, and we quit it, and we go back at it, and we say instead of 3 3 we say 3 or just 4 5. That can happen. So we get 20 number of rooms is 20, then 4 3 3 3 3 4 3 3 3. I think that is correct. Alright, so that is correct, that is checked. Is that over at my, just a second. Yes, sorry, I thought that was my notification. It was not. Oh shit, I closed it. Oh fuck. Oh my fucking god, what did I do? Oh shit. Oh my god. Oh! Are you for real? Well, that concludes our video. Have a nice one. Tee-hee!